Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hi, everybody. Tonight we'll be doing the review for test number 4. Let me just remind you. This Thursday, I'll be giving test number 4 online. And don't forget, test number 4 will cover polymers, lipids, and carbohydrates. Now, test number 4 has 54 points general knowledge. Whoa, wait a second. What is that? Never seen that number that high. I'll explain that in a second. 15 points nomenclature and 36 points reactions. So there's five bonus points. Now, why is there 54 points general knowledge? Well, in the carbohydrates, if I ask, is your right hand chiral or achiral? Well, that's not nomenclature. It's not reactions. It must be general knowledge. Or if I ask you to draw a diastereomer, again, not nomenclature, reactions, general knowledge, which is why there's so many points. All right. One other thing I want to remind you, a week from tonight, I think it is the 6th of May, is the deadline. I think it's the 6th of May. It's the deadline for the optional extra credit project, which is worth 10, yep, 5 and 5 is 10 bonus points. Remember, as a public service to you, email me your list for the extra credit project before it's due. I'll check it. And if there's something wrong, I'll tell you got to fix this. That way, it shouldn't be hard for everybody who puts in a little time to get 10 bonus points. I'll give you an example. Don't tell anybody I'm being nice. Carmex, which is for your lips, good product. And if you look at the label, one of the compounds is phenol. And there are two different functional groups. You only have to name one if there's more than one in a molecule. One is an alcohol. The other is a benzene ring or aromatic. And guess what? You can use this on your project. So you already got 1 point. You only need 9 more, or you can do your own 10. Now, one thing I do want to mention, somehow people think, well, 10 molecules, each one has to be a different functional group. No, if you want them all to be alcohols, as long as they're different molecules, that's fine. Or ketones or aldehydes, but they have to be 10 different molecules. So even though phenol has a benzene ring and an alcohol, you can only use it once, but you have to pick one of the functional groups. All right, let's get started. What you see on your screen, which is test number 4 review by me, is available in the lecture section of Blackboard with the secret name Test 4 Review. Now, if you go scroll to the bottom this time of the semester, you may have to click on the button that says More to see the whole list, to see this. All right, let's get started. Things you should know. You should know what is a polymer. It's a macromolecule, which means it's a big molecule made up of repeating units called monomers. Now, there are different types of polymers you should know. First one is an addition polymer, and that's a polymer made up of one type of monomer. And examples, which you should also know, rubber things like your rubber car tires are addition polymers, and saran wrap, otherwise known as plastic wrap, used in the kitchen, is an addition polymer. Next, you should know what a condensation polymer is. And a condensation polymer is a polymer made with 2 different types of monomers, or more than 2 different types. An example would be my plastic bottle, which is a polyester. Remember, ester, carboxylic acid, alcohol, two different types of monomers. And if I had my nylon jacket on, which I don't, this is cotton, which is another type of polymer, but I won't go into that now. That would be an example. Now, there's also two ways of identifying polymers by physical property, a key one. And you should know a thermoplastic polymer is a polymer once formed, it can be reheated and reshaped. An example is my water bottle or saran wrap. And there's no relationship between addition condensation and thermoplastic. You just got to find out. Now, the other type is a thermoset polymer. And once formed, it cannot be reheated or reshaped. An example of that is rubber tires or urethane foam, which is the polymer in things like your car seat and a lot of your pillows, your furniture have foam padding, and that can't be reshaped. And if you look at video from areas in the world under strife, you'll see that a lot of times they block the road with car tires and they set them on fire. Why? Because they don't melt, they just burn. Those are thermoset polymers. All right, next I talked about fats and oils, and this is lipids. Now, a lipid is a molecule from plants or living things like us that are soluble in nonpolar solvents and not soluble in water. Now, you should know there are two types of lipids. One is saponifiable, the other is non-saponifiable. And you know saponifiable, there's saponification of an ester. In this case, a saponifiable lipid yields carboxylate anions of fatty acids in a reaction of base and water. Non-saponifiable lipids, which are also known as steroids, do not react or react with base and water. Now, the saponifiable lipids are also called fats and oils, which is an industry Dr. White worked in. I did. And you should know, first of all, what is a fat? A fat is a solid or semi-solid triglyceride at room temperature. An oil is a liquid triglyceride at room temperature. So if we say, if you make bacon in a frying pan and you see the fat left over from the bacon, after a while, when it cools down, it becomes a solid because it's a fat. If you have vegetable oil or olive oil in your house, outside at room temperature, it's a liquid. Now, the general structure for fats and oils is this triglyceride. And remember, an ester, synthetic organic chemists write it this way. Oil chemists, which means we deal with fats and oils, write it backwards. But these are esters. And notice in the triglyceride, this is the general structure. We have 1, 2, 3 esters. Now, these esters undergo all the reactions you learned for test 3. So as I promised, I'm not going through any major new reactions. So if I have acid hydrolysis or fat or oil, you take an ester, react it with acid and water, you get back the alcohol and the carboxylic acid you would have used to make that ester. Well, you've got, guess what? 1, 2, 3 esters, acid and water. Ester number 1 gives us alcohol plus this carboxylic acid. Ester 2 gives us alcohol plus this carboxylic acid. And ester 3 gives this alcohol and this carboxylic acid. I won't ask on a test, but I worked in this industry, so I'll say it. This molecule is glycerin, which is an important ingredient in the industrial world and also in cosmetics and other things. And these carboxylic acids that come from fats and oils are called fatty acids. Why? If we take an ester based in water, you get back the carboxylic acid, the alcohol plus the carboxylate anion of the carboxylic acid you would have used to make that ester. Well, guess what? Same thing happens with a fat or oil, except you have 3 esters. And ester number 1 gives this alcohol and this carboxylate anion. Ester 2, this alcohol and this carboxylate anion. Ester 3, this alcohol and this carboxylate anion. Now, something different that I didn't talk about for test 3. And that's, how do you make a reaction go faster? Well, one way is add a catalyst, like acid or base, which is what we've done up here. The other way is, for a lot of reactions, run it at a hotter temperature. There's a rule of thumb, see it's on this thumb, that for every 10 degrees C, for most reactions, the reaction rate doubles. So if you react the ester with steam, which is very, very hot water, this is the same as acid hydrolysis of an ester. You get the alcohol and the carboxylic acid you would have used to make that ester. Well, guess what? You have ester 1, 2, 3. And ester 1 in steam, which is hot water, which gives you the same products as acid hydrolysis of a fat or oil. You get glycerin and these 3 fatty acids. Now, I only asked you to learn the names and structures of 2 fatty acids. And these are the common names because nobody uses IUPAC names if you work in the industry, and I did. In fact, one company I worked at where they made oleic acid, they're still selling 2 types of oleic acid that I invented. That was a long time ago. They're still selling it. But anyways, stearic acid is a carboxylic acid with 16 carbons, and it's a saturated fatty acid. All carbon-carbon single bonds, all carbon-carbon bonds are single bonds. And instead of writing out 16 times CH2, I'm now using the paren CH2 close paren 16. 16 plus 2, 18 carbons. Now, I say 16 before, it should be 18 carbons. Now, oleic acid also has 18 carbons, but at carbon number 9, there's a double bond. And so we have 1 plus 7 is 8. This is 9, double bond. And total of, again, 18 carbons, but there's a double bond. And this can be cis or trans. Now, as I said earlier, stearic acid is a saturated fat, or I should say, comes from a saturated fat. And you should know a saturated fat, and this is important, has only carbon-carbon single bonds. Don't say only single bonds, because it has a carbonyl, 3 of them, and that's a carbon-oxygen double bond. But saturated fat has only carbon-carbon single bonds. Unsaturated fat has at least 1 carbon-carbon double bond. Mother Nature never anywhere did triple bonds. All right, because I worked in this industry, you get to learn some things that are really not in the book. And that is, you should know, what is tallow? Beef fat. What is yellow grease? Pig's fat. And what is white grease? That's another grade of pig's fat. And you should know this. Now, because I worked in this industry and the company I worked for used to buy about 2 to 3, are you listening to this, million pounds a week of these things, tallow, yellow grease, and white grease. I was involved in that. I know that tallow, yellow grease, white grease has a similar structure. And on a test, if I have you use tallow, yellow grease, and white grease, this is the structure you should use. And R sub S means when you saponify this ester, you'd get stearic acid. R sub O, oleic acid. And roughly there's about a 50-50 mix. But how do you do 50-50 when you have 3 esters? Well, you just play a game and you do RSOR, SOS, ROS, or SOS. Therefore, if on a test, I ask you, give the 3 products that you get when you react tallow with sodium hydroxide and water, you should know this is a triglyceride, which is an ester. Here's a general reaction. And because this is the structure you should use for tallow, yellow grease, white grease, the reaction I'm asking you to do now is this one. And you have 3 esters, 1, 2, 3. Ester number 1 gives this alcohol and this carboxylate anion. Because the R group is not R prime, it's R sub S. This would be called sodium stearate. Ester number 2 gives this alcohol. Plus this carboxylate anion of the carboxylic acid you would have used to make this ester, oleic acid, and so you get sodium oleate. Now, ester 3 gives this alcohol, but it gives this carboxylate anion again. But if you look at it, there are 3 different products. I don't ask you to balance an equation, which is why I wrote the 2 very small. Now, you should be able to do the same reaction with acid and water. I've done it with base and also steam. The only difference is instead of R prime and R double prime, you get R sub S and R sub O. And the company I worked at, we did it with steam, tune of 2 to 3 million pounds every week. That's big scale. All right, one of the things I would like you to know, leaving my class, how does soap work? Let me make myself real clear. One of the things, hint, big hint, real big hint, you should know, leaving my class, how does soap work? So let's go through it. You should know the structure of soap is a nonpolar tail and a polar head. And dirt and grease, oops, forgot an E there, it fell off somewhere, are polar. I don't have here, but you should know water is the most polar thing. Remember, you did a lab there. Now, the most important part of the puzzle, notice it says key, and it's in red. That means it's important, is like dissolves like. Things that are polar are soluble in polar things. Things that are nonpolar are soluble in nonpolar solvents, and you can't mix 2 together. And you should know how to draw. Here's a little piece of dirt. And because dirt is nonpolar, it attracts the nonpolar tails of soap. Because if you just do water on your hands, it's not going to get them clean. Luckily, I use soap, so my hands are clean. Uh-oh, it's bad humor night. Anyway, that was pretty bad. But anyways, and the polar heads want to stay as far away. And you get a lot of soap molecules that's totally encase the dirt particle. And you should know this forms a micelle. And the micelle has the polar heads on the outside And inside, where water can't see it, is a little piece of dirt. And water says to the micelle, I'm polar, you're polar, you look polar. Let's go down the drain together. And they do. And you should know this. Again, you should know how to draw a structure of soap. You should know the key to the puzzle is like dissolves like. You should know how to draw a micelle and explain why water now interacts and goes down the drain with the micelle. All right, next I talked just briefly about steroids, and you should know how to draw the steroid ring skeleton. And that's a 6-membered ring here, 6-membered ring, 6-membered ring up here, and 5. And I'll do one in real life time. 6-membered ring, next to it is a fused 6-membered ring. Then up here at 12 o'clock, another 6-membered ring fused, and then at right here, a 5-membered ring. So there are 4 rings, and they're called A. You don't have to know this B, C, and D. Ooh, Dr. White knows his alphabet, look out. And you should know how to draw that. All right, now we went into the next area, and that's carbohydrates. This is a very fattening chapter. And what are carbohydrates? Those are polyhydroxyaldehyde or a polyhydroxy ketone. Remember, poly means many, hydroxyl, OH group, ketone or aldehyde, or a molecule that upon hydrolysis becomes a polyhydroxyl aldehyde or polyhydroxyl ketone. At this point, I started talking about an important concept called chirality. And you should know chirality means handedness. In Greek, and actually a number of years ago, one semester I had 2 Greek students from, guess what, Greece. And they said, yes, that does mean that, because Dr. White doesn't speak any Greek except I like the order gyros, but that's not chemistry. All right. When we talk about chiral objects, there are 2 types, achiral and chiral. Now, a chiral object is an object with a non-superimposable mirror image. I won't ask the definition of it, but you should know how to identify objects that are chiral or achiral. The A in front means without chirality. So an achiral object is an object that with a superimposable mirror image. Now, if you see the name or description of an object and it has the word left or right in it, immediately you know it's chiral. Right hand is chiral. Left hand's chiral. Non-superimposable mirror image. See, here's the mirror. By the way, does everybody know what this is? Spider doing push-ups on a mirror. Anyways, I have to throw that in. Ooh. Anyways, I have to. You should know things like, and I went through that in a video, is a needle, sewing needle, chiral or achiral? I'm not going to ruin your day and show you my artwork. I already did that in the videos. But a sewing needle has a superimposable mirror image. That means it's achiral. How about your left winter glove? Oops, the word left, that means it's chiral. Next, I talked about chiral carbons. And chiral carbons are any carbon with 4 different groups, 4 different atoms, or a combination of 4 different groups or atoms. And if a carbon in a molecule has 2 or more of the same atom or groups, immediately know it's not a chiral carbon. and let me share some of the fun. Oops, that should be a 2. All right, I'll let you have some fun first. Circle all the chiral carbons. Your turn. And while you're doing that, I can get a refill bottle of water. I'll be right back while you're working on that. I'm back. Everybody done? Give me a thumbs up if you're done. Okay, so if you look at this molecule, this carbon has 3 hydrogens, so it's out. This carbon is in a double bond. If it's in a double bond or triple bond, it's out. These are in a double bond. They're out. So that leaves us 2 carbons. This one has a hydrogen, hydroxy group of methyl, and all this. So it's chiral. If we look at this carbon, has a hydrogen, a bromine, all this, and all this, and they're different. We call that R and R prime. So that'd be 1, 2, 3, 4 different things. And that's how you find and circle chiral carbons. Now, the next thing I talked about, which is important, are enantiomers. And enantiomers are non-superimposable mirror images of a molecule. So if I were to ask on a test, draw the enantiomer of this, what do? You draw the mirror image. And this is a Fisher projection. Remember, every intersectional line is a carbon. And if I were to ask you, draw the enantiomer of that molecule, 3 points each, why don't you have it tried out? Boy, am I sharing a lot tonight. And when you're done, give me a thumbs up. All right. So how do you draw the enantiomer of this molecule? You don't have to, but I like to put it in my imaginary mirror. Now, this is an achiral carbon. You could draw the mirror image. I don't. I'm lazy. I told you organic chemists are lazy. And this is an achiral carbon. If you drew it like this, that's okay. But these three carbons are chiral. So the hydroxyl group here is closest to the mirror, and that's what you'll see first in the reflection. The hydrogen is farthest away. Next carbon. This hydrogen is close to the mirror. Hydroxyl group is farthest away. And the final carbon here, OH, is close to the mirror. Hydrogen is farthest away. And here's the answer. That would be the enantiomer. If this is the original product, here's the enantiomer. The mirror image. And since these molecules are chiral, they're non-superimposable mirror image. Now, a very important reaction dealing with carbohydrates, and first with glucose, and you do not have to know the structure of glucose, but you have to understand this reaction, is if I have glucose and have this equilibrium, ask you to write the product, or if I give you this and ask you to write the starting material, you should know in general, you have a carbon aldehyde up here, could have been a ketone, you'll see that it is in a minute, and an alcohol on carbon number 5. And if we're not in the same molecule, you'd have an acid catalyst. This is a reaction you learn for test 2. You form a hemiacetal or hemiketal. Well, instead of having you learn, I forgot the name of the projections, Hawthorne projections, I came up with this world's ugliest single oxygen carbon bond. This red shows how this hydrox group attacks this carbon, carbonyl carbon like here, and you form this bond just like up here. You have the OH, this is part of your OR, and make sure you draw this bond in, because otherwise you didn't do any chemistry. And if this didn't happen, we wouldn't have any starches in our world. That's sad. All the good stuff, pizzas, French fries, rice, potatoes. The good stuff, French fries. No, I haven't had a French fry in many, many years. My cardiologist is very happy with me when I say that. All right, next, if you have fructose, you now have a ketone here in carbon 2. On carbon 5, the same hydroxy group alcohol, same reaction, because it's in a molecule together, it's called inside the same molecule. You don't need the acid catalyst, that's why you have this equilibrium. And this reacts to form a hemiketal. This attacks that, and this carbon has an OH group, and this oxygen to that carbon, which this right here is this bond, and this is that, and this carbon is that carbon. And you should know how to do this. If I give you the structure of fructose and an equilibrium arrow, you should be able to write this product. If I give you this product, equilibrium arrow, you should be able to draw the structure of fructose. And fructose and glucose are 2 sugars and that are important in nature. Now, one other sort of a new reaction is if you have the hemiacetal, and I only do it for glucose, and you react it with an alcohol and acid, just like here, the hemiacetal, you replace this OH with OR triple prime. And this is the basis how all starches are formed, which I'd say is pretty important. Let me know when you have it all copied down. Give me a thumbs up. Okay. All right. Now, there's some key words you should know and understand. Table sugar, also known as sucrose, is a fructose and glucose molecule bond together in an acetal linkage. Starches, the good stuff in life like pizza crust, good bread, potatoes, rice, you go on and on, are polyglucose, glucose molecules held together in an acetal linkage. So what does that mean? Well, if you take a lot of glucose and acid catalyst, you'll make starch. And guess what another name for an acid catalyst is? Enzymes. Most enzymes are very fancy acid catalysts, but we don't get into that in our class. And like I said, the linkage is an acetal. So if we take water and acid like in your stomach, when you eat sucrose, that breaks it down to fructose and glucose. And you should know this. And when you eat something with starch, like I had some rice for dinner, right now in my stomach, that starch is being broken down by the acid in our stomach. That's hydrochloric acid, which I think is one of the miracles of life, that we all have cells in our body that make hydrochloric acid. And you've been seeing me drinking water tonight, and you drink water, and that breaks down to glucose. And that's the sugar, main sugar in your blood. All right, now, leaving my class. Hold on. Hint, big hint, real big hint. Leaving my class, you should know when you eat a fat or oil, how to describe with words and a general reaction what chemical reaction happens in your stomach. And I got corrected one year by someone who knows physiology. The last biology I had was freshman year of high school. Not that there's anything wrong with biology, but by then I knew I was going to become a chemist. And that is also, I forgot which intestine it also breaks down too. You should know when you eat a fat or oil, what reaction is going on in your stomach. Describe it with words and a general reaction. Fat or oil is a triester, triglyceride. Therefore, that's acid hydrolysis of an ester. The general reaction, ester, acid, water, you get back the carboxylic acid and the alcohol you would have used to make that ester. Again, you should know how to describe with words and a general reaction what happens when you eat a fat or oil. And that's acid hydrolysis of an ester. By the way, I don't want to scare you, but this goes on in your stomach and intestine, one of them. But anyways, and here's the general reaction. Ester, acid catalyst, H plus, water, to get back the carboxylic acid and the alcohol you would use to make that ester. You learned that for test 3. The other, at this point, reaction I want you to know and how to describe with words in a general reaction is when you eat a carbohydrate. Again, in your stomach is acid and water. So that's acid hydrolysis. What functional group holds glucose molecules together in starch? An acetal. So that's acid hydrolysis of an acetal. And the general reaction, which is for acetal or ketal, which you learned for test 2, is acetal or ketal, acid catalyst, H plus, water. You get back an aldehyde or ketone plus the alcohol, and you don't have to put 2 there because you don't have to balance things. My class. and the alcohol you would have used to make that acetal or ketal. Again, you should know how to describe with words and a general reaction what happens when you eat a carbohydrate. And that's acid hydrolysis of an acetal. Here's the acetal or ketal, acid or water, and you get back the aldehyde or ketone plus the alcohol you would have used to make that acetal. Turns out they're in the same molecule we call glucose. And with that, I'm done. Remember, for you to practice problems, that they're your friend. And a lot of you are, because a lot of you are doing very well, which makes my heart feel good. Thank you. And I'll stick around afterward if there are any questions. If not, I'd like to thank those who showed up tonight, and also all of you who are going to watch this video, which I'll post in a little while on my YouTube channel. And with that, I'll say in Yiddish, "Gang gesund." You know that means go in hell. COVID's still out there, and other nasty things are out there. Someone I know just got over a bad case of the flu, not me. I still wear my mask when I go into places like supermarkets or other crowded places. But I'll say "Gang gesund," and I'll say goodbye. Stole that from Franny and the Beverly Hillbillies. Bye now.